question to me about, well, what about recycling? And so that is a challenge, just like for the electronics folks. I mean, you have a resin and you have a fiber in that composite material, and they're tightly bound. They're chemically bound to each other. So, you know, there's a real engineering challenge about how do we get those things apart so that we can use them again. Not necessarily, you know, I'm not saying we're going to use that same fiber again, but we've got to get it back to some kind of raw material so it can be turned into something new. So that is a challenge that composites have. That's another thing that sort of slowed their use in the auto industry in Europe, because there's legislation here in Europe about the end of life, about recycling of cars at end of life. They have to be recycled to a certain extent. So the car companies are a little weary right now of putting more composites on there because of this recycling challenge. But their day will definitely come, because with gas prices as high as they are, cars are going to have to continue to become more fuel efficient. And one of the big ways to make that happen is to make them lighter. Yeah. So, I'm not sure exactly specifically what you're asking. So hydrogen definitely is less energy dense. So if I talk about it in terms of mass, and even if I talk about it in terms of volume, even if I compress it all the way down as far as I can, or even if I cool it down, with hydrogen, you can't only compress it down to be a liquid, but I can cool it down to be a liquid. But even as a liquid, it doesn't contain the same amount of energy as gasoline does. So as a consequence, you do need, you have to make up for that somehow. But what people that we interact with in the auto industry tell us is that their view of new technology, at least now I don't know, if gas prices were to continue to go up, maybe this would change. But their view is you can't introduce a new technology unless it does at least as well, if not better, than what people are used to. There was a law in the early 90s in California, in the United States, that required auto companies to sell electric vehicles. They were going to have to sell 2% of their fleet, and they were supposed to grow to 5% by now. And so they all made and designed electric vehicles, but no one would buy them because they couldn't go as far. They could go fast. An electrical motor could really give you a lot of torque, but you didn't have the range that you could get out of a gas vehicle. And so people the cars were sitting there, but no one would buy them. So the law had to be repealed. But their view is that you can't put, at least right now, if it's not better than the last one, the customer doesn't want to see it. So they would, you can get as much power as you want out of it. It just means the fuel cell or whatever has to be bigger than otherwise. Yeah. Does MIT? Yeah. So my research is probably about 80% funded by companies, and I would say the reason why. So MIT's mission is to impact the world, and it's not about just creating new knowledge. It's creating a difference. And so the fastest way, the best way for me to know that I'm working on a relevant question is if somebody in the company cares about it. And the fastest way for me to get new research results out to change what engineers, what scientists are doing, is to have that company. So I might write a paper and that gets in a journal, and hopefully lots of people will read that or whatever. But I can hand that result to the companies that I work with, and within months, their engineering practice is changing within General Motors, with Packard, within aluminum companies that we work with. We see that immediately. So that's why we engage with companies: is find relevant problems and make sure that what we do gets in the hands of people that can use it. Other questions? Oh, yeah. How do we get the attention of companies? Yeah, that's really a challenge. I mean, if you know, historically, universities got money from the government, and that's what paid for research. In the U.S., much earlier, my understanding from universities here is this is starting to happen here, is that the government is pulling back that amount of funding. So universities basically are saying, well, if we're going to continue to do work, to change the world, then we're going to have to get money from somewhere. So that happened in the U.S. probably 20 years ago. So we've kind of already gone through this transition of really interacting with companies. But basically, I would say a couple of different routes. Sometimes it's really just, so the way that we got into electronics recycling work was we made up a little brochure of the kind of work that we could do, and we sent it out to all the major manufacturers, to Hewlett-Packard, to Apple, to Dell. And, you know, to be honest, we sent it out to 20, and only 3 of them responded, and we're still working with those 3 folks. We could probably now go out and get others, but we have a good enough relationship with those, and so that's how it works. The other way is, you know, probably the less likely way is that sometimes we write papers, and people in the industry see them and say, you know, that would be really useful. I can see the use for that. And so they actually contact us and say, hey, can you change the way that we... So that happened for us most recently with Procter & Gamble, which is a big multinational company that sells sort of household products in the U.S., but they also happen to own one of the big battery makers in the U.S., Duracell. So they want to know how can they recycle their batteries, how can they make it possible to recycle Duracell batteries. And then we got a call from Alcan, which is one of the 3 biggest aluminum producers in the U.S., saying, how can we figure out ways that we can use more aluminum scrap when old aluminum products to make new aluminum products. So those are sort of the mechanisms. Sometimes it's getting on the phone, and then sometimes, fortunately, you might have some things out there that people see and contact you. Other questions? Yeah, okay, follow-up question there. Great. I don't completely. What's the question? Sorry. I understand. Yeah. Okay. So in the U.S., so again, our funding model for college is very different than you guys is. So you should certainly talk to some of your instructors here because I don't know how the European system works particularly well, but I'll tell you how the U.S. system works. Is that in general, your undergraduates or your first few years of university in the U.S. is financed by the student themselves. Now, there's lots of scholarships that are out there, but what most students do is take out loans, and the federal government basically subsidizes those loans, so they have very low interest rates. And then for engineering and science, for graduate school, so to get your master's degree or your PhD, that's where, so the company gives me as a researcher at MIT money, and then I hire a graduate student, and that covers their fees, and then it also covers their what we call stipend. So that's their sort of pay to live on while they're in school. So that's sort of the way that works. Now, professional schools in the U.S., so medical, dental, law, those kind of things, those are also, or veterinary, those are all financed by the student. There's not a company that pays. That's what my wife did, so every month I write a check to pay off her loan. But other questions? Oh, okay, another question. Yeah. Right, so the question was whether MIT uses clean energy sources or whether there are projects or opportunities for students to do so. So right now MIT is undertaking an environmental audit of all of its activities, which are sort of, this is going to be aimed at basically coming to a conclusion on that. So historically, that wasn't the case. We actually have our own, we have our own power facility there on campus, and so it is natural gas. It is sort of state of the art, but there's a review going into how basically we can become greener as a campus. In terms of projects for students, I would say there's the greatest thing about MIT is it's driven not so much by the faculty as I would say about the innovativeness of the students. So there are students involved in solar car competition, so basically building, a car that runs just on solar power. There's this, it's a sort of like the Robo Cup. There's a global competitive project about that. There's a team on campus that's doing a solar house, so a house which runs just off of the solar panels on the roof of it. But there's a lot. What I would say is sort of the other thing that's really nice is that undergraduates, all the way up to graduate students at MIT, become involved in the research, just like research projects that I was just telling you about. So in addition to the graduate students that work in my group, there's several undergraduates that work on these projects, and so the faculty that work on solar cells, or the faculty that work on fuel cells, they have undergraduates working in their labs as well. So there are these big things like solar car or solar house, but there are also lots of small projects that are up inside of each faculty member's labs that basically give opportunities for students to sort of learn about these things and make an impact as well. Yes? No, you apply, just like, yeah, absolutely, yeah. Now you need to have an undergraduate degree first, but once you, but yeah, you would apply. Yeah, and you can just, if you go on the website and, just right on the home page for MIT, you'll find sort of instructions on how to do that kind of thing. I'm really not an expert in it, but there are other folks that's what they're in charge of. Any other questions? Oh, another one. Okay. So the diplomas will be given by the partner universities in Portugal here. So I'm not involved in all four. I'm just involved in the one of design and manufacturing. So in that, you get a diploma either from IST, Porto, University of Porto, or University of Vienna. Those are the three partner schools for that program. So that would be who the diploma would come from. But those diplomas are certainly recognized in the U.S. Absolutely. Oh, yeah. Was there a question? This is one of the questions that I heard about ahead of time. So do I worry about robots becoming too intelligent, like in the Terminator movie? Okay. It's definitely not something I personally worry about. It strikes me as we have a heck of a long way to go for anything really close to something that's that capable. But I also have to admit it's really not my expertise, so I think I would probably have to defer that. I sort of sent that question around to a bunch of folks on campus to see what kind of response I got. I got a bunch of websites, fan websites, rather than anything really insightful on it. So unfortunately, kind of gone outside of anything I could really intelligently comment on here. Other questions? Oh, another one. Okay. You guys all sat in the back row. Okay, fuel source. Okay. Yeah, so right now, I think that so this is something that we're actually starting a project with General Motors to really the different fuel options that are out there. You know, it's really interesting. Right now, we're at a cusp point, I would say, in terms of fuel sources. The head of R&D at General Motors showed me this photograph from a gasoline station in California that right now offers, I think it was 12 different types of liquid fuel. So, you know, there's 3 different, gasoline at different octane levels. You could buy regular diesel. You could buy diesel made from corn. You could buy diesel made from old oil from restaurants. You could buy ethanol. You could buy liquid propane. I'll forget what all of them are. But right now, all the companies are experimenting with lots of different options. It would be silly to speculate and pick what the best one's going to be, because I think there's way too much that's going on to really guess that. But a couple things I would point out. One is that oil is going to be around for a long time. So when you hear about the peak in oil production, that people talk about a peak coming sometime in the next 30 years, that's what we call conventional oil. So you drill down and there's sort of a big pocket of oil there that we pump up. But there's a lot of what people refer to as non-conventional oils that are out there that are not so nicely segregated. So there's a huge field of oil in California, in Canada, in North America, which is basically all tied up with sand. It's just directly integrated in with sand. Well, the problem is that it's a lot cheaper to just drill a hole and pump something up. So right now it's not economical for somebody to go in, collect that up, and then actually segregate all the sand so that we have oil available. The other thing is there's a lot of work going on right now to figure out how to turn coal into a liquid fuel. And we really globally have a lot of coal. So, I think that traditional hydrocarbons are going to continue to play a role for quite a long time. Now, that doesn't mean that there's not a lot of growth of other really non-traditional things as well. So, the U.S. auto companies are putting also a big bet into agriculturally derived liquid fuels. So, the big one that's sort of controversial in the U.S. right now is to grow corn and convert that into ethanol, which then you can burn you can basically drive your car on ethanol. So it turns out that it takes a lot of energy to grow corn, so you don't really come out all that much ahead. In other words, you put so much energy into growing corn just to get this energy out to drive the car. But there are other crops that make a lot more sense. So actually, Brazil is probably the leader in this. I think it's somewhere around 25% of the fuel that they use for automobiles comes from sugarcane. And you just get a lot more. It takes less energy going in per amount of energy that you have coming out. And then there's a lot of work going on in the bioengineering arena to take things that grow on very little energy, so basically grasses of various kinds that sort of grow in marginal areas, and basically develop microbes that kind of eat those and turn them into liquid fuel. And there's been a lot of exciting developments in that over the last couple of years as what seems to be a productive direction for us to go. The other problem, I heard one of the major auto execs a couple of weeks ago point out you're not going to see corn grown in China in order to drive their fleet. And the reason is because in China, all of the space that they have currently, at least, given current technology, they grow corn. That corn goes to feed people. So if they took some of that area to drive cars, then they wouldn't have enough corn to go around. So that's why these technologies of grasses that can grow in more marginal areas where you wouldn't actually be competing with food sources are really an exciting direction, at least for that kind of energy source. So I think there's a tremendous variety out there. There's also hydrogen, like I mentioned before, which there's a tremendous amount of money being spent on those technologies. So I think you're going to see those things sooner than you might realize. Other questions? I'm going to run out of voice here. Just leave it. Seems like that might be about all. I'm not sure who I'm who I should turn the microphone over to. Okay, just tell everybody that we're done. Is that basically okay? Well, hopefully you guys have seen it. We've gotten at least a little bit of a flavor about at least my little view of why engineering is an exciting area to go into. I think there's a lot of challenges that are going to confront a technological world over this century. My little corner of that is to focus on the environmental problems associated with it. But there are tons of associated, I'd say, development problems as the rest of the world wants their iPod, right? So how are we going to scale that production economy up? And that creates a huge opportunity for folks like yourself that want to pursue engineering and science. So I thank everybody here for giving me the opportunity and appreciate that. It was certainly interesting to hear about the robots. Hopefully I can have some time to chat with some of the folks that were involved in making it here afterwards. But thank you very much.
I wish to thank the Dean and the session for being very important.